diamond ring for my queen. You gon' wait me till Jesus come. Why when I talk? Pocket full floss, money, honey. Forget about Suzanne. So since we don't have all the equipment like cameras and all this stuff, so just use one of the webcam from my computer. So we're gonna start with these tools and give people knowledge, because that's how they say, start with what you have, and then from there you're gonna elevate it. You're gonna elevate it, and things gonna propagate it, and excuse me, and things gonna improve slowly, because you can't reach down top before start from the bottom. Otherwise, then you're gonna break and start from bottom of phrase. So we're gonna start. I'm gonna start with the tool that I have, this week. Go to before start from top player. Hello, brother and sister. We're live again on television camera, as you always do. So let's get started. Live and direct on television camera, we have equation. Find the arc of a length of a function y squared equal to x cubed between x equal to 1 to x equal to 2. So first and foremost, brother and sister, so I want you to get the arc length. So first and foremost, you need to know the formula of arc length. So the equation, so this arc length along the x-axis, this arc length along the x-axis. So now I'm going to say we have equation, solution, equation fourth of arc length. Okay, so we got two types of equation of arc length. So I assume this is the arc length along x-axis, along x-axis. So this is equation of arc length along x-axis. So arc length as represented by x equal to say integral from interval a to b, for this case 1 to 2, mean this value of x interval, and then we're gonna say you write your square root, and here it's gonna be 1 plus, and then got dy over dx bracket square, and here is dx. That's how you get the arc length along x-axis. So now first and foremost, we know a. What is a? A the first interval, b the second interval. So the problem only dy dx squared. That's what we need. So this is what we need now. So you need to memorize this, because in exam they're not going to give it to you. Now let's go. Let's get it. So now we're going to say, okay, so I'm going to get dy dx. I have to take y squared. Take my y squared given equal to ax cubed. So I'm going to differentiate left and right. When I differentiate here, it's going to give me 2y, but I differentiated y, so I'm going to have to say give respect dy. Now go to the right hand side. 3 times 8 is going to be 24. Now x, 3 minus 1 equals 2. I differentiated x, so I'm going to say give respect for dx. Right? So I'm looking for dy over dx. So now I have to make what? I have to make something equal dy over dx. So I'm going to get dy over dx, so I have to divide by dx, because I want to get dy over dx. Divide by dx throughout. This one is going to go. So on the left hand side, I'm going to be left with this and this stuff here, but I don't need it. I just need dy dx, right? So I'm going to say, okay, I'm going to write my dy dx equal to 24x squared, because this and this cancel. So I don't need 2y, so divide by 2y throughout. Divide by 2y and divide by 2y. So this and this go. So dy dx equals 24x squared over 2y. So I'm gonna eliminate this one, because I don't need it. I need dy dx. See what I'm saying? And another thing also, look. So now I'm gonna say, but I need dy dx in terms of x's. So I don't need this y, but I want the value of y equal to, if y squared equal to this, meaning y equal to square root, because of square root left and right equal to square root of 80 x cubed. So here in the position of y, I'm gonna replace the y dx equal to 4x squared over 2, and then we have what? 8x cubed. But what do I need here? I need dy over dx squared. So if I square on the left, I have to square also on the right, so I can get dy dx squared. So dy over dx equal to, okay, 24 over 2, this let me say, 12 8x, so long before we square, right? Over 2, and then we have what? 8x cubed before square. Now we square left here and have to square right. So that's what we're going to square. We're going to say, okay, equal to 12. What am I doing? Excuse me. There is no 2 here because 24 divided by 2 equal to 12. So no more 2. No more 2. We'll have a square root of 8. So we're going to square on the left and square on the right. Means x square, and then we have 80x cubed. Right? X cubed. So here also we're going to square, and here also we're going to square. So some of this stuff here is going to cancel. So now it's going to be 12 square equal to 144, and then x power 4 over. Now when you square in this, means this and this going to go, because look, the square root of 80x cubed. If you square this and this cancels, so you left with 8x cubed. So top one will square, we get to 1144, and this x power 4 denominator is going to give us 8x power cubed. 144 divided by 80, we say equal to how many 80 in 14? Because how many 8 in 1 is too small. How many 8 in 14 is going to be 1, but we're going to be left with 6. How many 8 in 64? 18. And they have it. Okay, this 3x go, 3x go. So only left with what? With only 18x. Right, so d square dy over dx square equal to 18x. So now what we're going to do now? Come on, you know what we do. So we're going to take this value here, which is dy dx square, plug in here, and now we have a. A is the first limit to the last one. Let's go. So I can just do here. Excuse me. So I'm going to say my arc length along x-axis. I'm going to start from here. So my arc length along x-axis equal to integral a. What is my a? A the first limit, which is equal to 1 to the b equal to second limit, and now we go square root 1 plus dy over dx square equal to 18x, and they got dx. So this is the power of integration. This is the power of integration. But if it's me, you know what I'm gonna do? I'm gonna, now it's normal integral, I'm gonna let the inner one, because this is like a power rule, but I want to make it easy. So I'm gonna let, let's say u equal to 1 plus 18x. So when I differentiate, this is going to give me the u, and when you differentiate, this is going to be 0 because it's a constant. When you differentiate, this is going to give us 18x dx. 18x dx. See, that's going to give us 18x dx. And then, alright, so I think I made a little mistake. When you differentiate, it's not 18x dx, just 18x. I apologize. Means when you differentiate 18, it's going to give us 18x, going to give us 18 with respect to dx. So now look here, man. Dx, we can everything we're going to replace. We're going to do substitution. So dx meaning du over 18. Okay, so our dx, du over 18 equal to dx, and this stuff here equal to u. So we're going to say arc length. Excuse me, arc length equal to integral 1 to 2. So all this stuff we know is u. 1 plus 18 equal to u. So u, and square root meaning a half. If I don't want to use square root, I could say a half. And this is dx. What is dx? Du over 18. So du over 18. The question is finished. It's almost finished. Now we say equal. So this 18 is constant, so it's going to go outside because it's going to go before the integral. So say 1 over 18 because at the bottom, so it's going to go at the bottom, and then we say integral 1 to 2. Okay, this is u a half du. Okay, let's go. So now we're going to see our arc length along x-axis. Now 1 over 18. So this is the power of integration. So what we're going to do, I want to take this plus 1, means a half plus 1 equal to, so we're going to have a u. A half plus 1 is going to be 3 over 2, means you take this power u plus 1 over divided by the same thing, 3 over 2, and then we know we're going to plus constant. You know why we know we're going to plus constant? Because we have a limit to 1 to 2. So I'm going to say 1 to 2. So the next things now, look. So now this is 1 over 18. Excuse me. These two here, look. These two are going to go to the top. So it's going to be this equal to 2 go here to the top. So it's going to be 2 over, have 18. And then times, we have a 3 here, the bottom, and they'll have a u 3 over 2, and then our limit start from 1 to 2. Now by 2, 1 by 2, 9. So 9 times 3, 27 equal 27. So we say finally, we're not finally yet. So now we say u 3 over 2, so this is going to be u 3 over 2 over 9 times 3 equal 20, 27. So we have our limit 1 to 2. So now we're almost there. So now the equation, they didn't give us in terms of u, because we did substitution, that's why it came as a u. So we have to substitute back with the value of u. So what the value of u, we did let some when u equal to 1 plus 18x here. So instead of u, I'm going to say u equal to 1 plus 18x over 27 over 27 over 27, and then we have 3 over 2, and then we have our limit. Our limits are from 1 to 2. So the last step, we substitute upper limit minus lower limit. Means, remember this is limit the value of x, so we're going to substitute in the position of x. So I'm going to substitute here in the value of x for all of these. So always remember upper limit minus lower limit. Okay, so now we're going to say our arc length equal, mean this value of x, upper limit is going to come in here. So we're going to say 1 plus 8 times 2, this is upper limit, and they have it 3 over 2 and over 27, and they're going to minus. Now we substitute the lower limit in this equation. So okay, minus 1 plus 80 times 1 over 27, and then 3 over 2. So plug that in the calculator. When you plug in the calculator, finally it's going to give to you the arc length equal to 5.26, and then add it 2, 6. So our arc length s equal to, if you round off, let's say round off like in 3 decimal places, it's going to be 5.2668, 68 somewhere there. Units. Why we say unit? Because the length, arc length, so this is a unit. So that's how you get arc length, man, along x-axis, right? So brothers and sisters, if this is the first time on my channel, make sure you click the like button, subscribe, try to share with a lot of people, and thanks a lot, man. Peace and love. Peace. And you know, you can share with a lot of people about this television company. So another time again, this is let me just show everybody so that everybody can see clearly. This is Mtwana Wabantu Academy. I'm saying, and the aim or the purpose of start this program is everyone should access free, classic, quality education for all. Means, you know, the aim